Hello folks, welcome to the channel. Today we're going to assemble a 2-ton telescopic gantry crane made by Titan Attachments. I'm in no way affiliated with Titan or sponsored by them, and purchased this unit with my own hard-earned dollars. I happened across this company, I believe, through a Facebook ad. Since I've been upgrading my machine shop and needed to move around and set my machines, I thought I'd give this product a try. Now, first thing to note about shipping is that this crate is quite heavy. If you order one for yourself, you want to have a way to help unload it when it arrives. I happen to have a skid steer around when this showed up and was able to get it off the trailer with zero drama. Shipping time, as I recall, was quite fast, so kudos offered on that front. The crate was pretty well put together and makes for good packaging. I did receive it with a fist-size hole in the plywood on one side, but I doubt that was any fault of Titan. Nothing appears to be damaged as a result, so that was a relief. There's a lot to cover here, so to keep the length of this video reasonable, I don't plan to dwell for long on the unboxing, and I think I'll just add a couple observational comments. First off, here the gantry beam is an S-shaped beam and appears to be an S6. I don't know if the paint is actually powder coat, but it seems pretty durable. Next up is the swiveling casters. Can't say I'm a big fan of nylon or plastic caster wheels. I've had similar casters deteriorate after a few years. These should be easy enough to change out with all steel casters though, if need be. These are the hand cranks for the cable pulleys that allow the columns to telescope. They seem quite adequately built. Here we have the hardware package. This is one of the plates that connect the gantry beam to the columns. There should be 2 per side. Again, I'm liking the coating on these structural members. In this package we have the safety catch pins and column clamping bolts. These are the diagonal braces that connect between the lower column and the foot support member. Alright, now that we have everything laid out, let's come up with the game plan. As a side note, I recommend getting a buddy to help assemble this and set it up. All my buddies were busy and I'm impatient, so I'm going to try to tackle this project for better or worse on my own. Fortunately, the column assembly, that is the upper and lower columns, as well as the cable and pulleys, come pre-assembled. First thing, I'll need to get this up off the ground since the support feet are going to be hanging off of each side. If I can get both columns connected to their respective support feet, I should be able to muscle the gantry beam into place and complete the bolt up. Since I'll need to roll this column 90 degrees to mount the gantry beam, I'm only going to want to attach one of the 2 diagonal braces on each column. The remaining braces will be attached once I get the unit stood up. Okay, so here we go. Both sides are mostly assembled and elevated. I don't have 4 sawhorses at my disposal, but I do have 4 pipe jacks and some timbers to span between them as a substitute. Now I'll need to mount the beam and column connection plates to the top of the columns before mounting the beam, after which I can attach the casters to the feet. It took a little trial and error with these connection plates. Ultimately, I arrived at the conclusion that it's best to not fully tighten the column bolts until the beam is installed, because bolt hole lineup is apparently a thing, if you can believe it. Now let's attach the matching connection plates to complete the pair at each column. Okay, so now both sets are in place and it's time to install the gantry beam. The beam isn't so heavy that it's unmanageable for one person, but getting everything spaced correctly becomes a challenge. I got a single bolt in one end just to capture the connection before pinning the opposite end. Once the beam end connections were captured, I installed the remaining column bolts and began aligning the remaining bolt holes before tightening. Okay, here's where things get sketchy and require thought and careful measurement. The only thing I have at my disposal to rotate this unit upright is an engine hoist. Now with the hoist arm fully extended at its highest point, I'll be able to clear the top of the gantry beam as long as the casters are not yet attached to the feet of the gantry. So, sounds like a winner to me. Let's try it. Now, I'm predicting the arrival of some comments regarding the use of a ratchet strap to lift this unit. Fear not, though, I placed some sling softeners between the corners of the beam and the strap to prevent abrasion, and if you weren't aware, ratchet straps do have a safe working load limit. Whatever that is, I'm sure it's much more than half the weight of the gantry, right? Okay, the unit is coming up off the support. Let's move that support and walk this thing until it's upright. Bingo! Now I unhook the engine hoist from the gantry beam. Once unhooked, I reconnect the strap to the lower column and lift one end to install the casters. Repeat that on the opposite side, and finally I attach the two remaining diagonal braces. And she should be good to go. The column safety locking pins and the column anchor bolts are installed. Those are the final pieces to be installed. Then it will be ready for a trolley and a hoist. This trolley is from Titan as well. It seems well built and heavy. A quick note about assembling a trolley. Now you're going to want as much of the wheels on each side engaged with the flange. Otherwise you increase local flange bending stresses and ultimately you just lose capacity. It's okay to have a small gap between the edge of the wheel and the edge of the flange to prevent getting jammed up as it's moving along, but you really don't want more than a 1/16 of an inch gap if you can manage it. It will take some rearranging of the spacers to get it right. Alright, so here we go. There she is. She's attached, and you can see a small amount of light between the flange and the wheel. That's exactly what we want. Just had to play around with the spacers. One last thing to unbox, and it is a 2-ton Harrington chain hoist. What's there to say about a Harrington hoist? I mean, they're proven and built to last. I just don't think you can go wrong with a Harrington hoist. Alright, the hoist and trolley are attached, and I must say I am pleased with how this looks. Let's see how high it can go though. Alright, this is the crane fully extended. Note the top, the shop is a little over 10 feet for reference. So yeah, this crane has quite a reach. Okay, I got the gantry crane inside the machine shop. Let's give this thing a load test, shall we? Now, I know that my lathe is roughly 2,000 pounds, give or take, so the load test isn't approaching 100% of capacity. Typical load test for cranes is 125% of the rated load capacity. At the moment, I don't have anything that weighs that much, so this will be fine. The lighting is horrible in here since I don't have main power ran yet, but still, I'm not seeing any deflection in the flanges, which is terrific. There is a dynamometer in this rigging setup to help verify the weight. Okay guys, I hope you've enjoyed this video and learned something from it. After I get this shop finished up and running with machinery set, I may do a review video down the road of this gantry crane. So like, share, subscribe, and comment if you would be interested in seeing more. We may get some machining videos out in the near future as well. So until next time, take care.